Hello, everyone. Thank you very much for having me here. My name is Nadim, and today I'm going to be talking about winning the crypto wars. I didn't come up with this title. It's a bit extra. But yes, we are going to be talking about interesting new technologies for enhancing the state of privacy on the internet in ways that are relevant for cryptographic and blockchain applications, as well as hopefully general purpose user applications. My job at NIM, which I started recently, is head of software integration, and my mission is to integrate NIM, the privacy technology that I'm going to be talking about, into as many different softwares as it makes sense. Stuff like Telegram, I don't know, Signal, secure wallets, and so on. Also, I am the author of a critically acclaimed puzzle adventure game called Dr. Kabushi's Labyrinthine Laboratory. I brought a few copies with me. Please take a copy. I will leave them here. It's a very nice puzzle game. It's got over 100 levels, an original soundtrack, pixel art, stuff like that. I really care a lot about this game. I spent like 1.5 years working on it. So I genuinely hope that you'll take a copy and try it out. It's available on Steam, Windows, Mac, Linux, and Nintendo Switch. But Nintendo would murder me if I tried to give a copy for free, so I won't. This is only for the Steam version. They're very strict, Nintendo. Their legal team is like the Yakuza. It's actually really insane. You should look it up. Anyway, so before I get fired for segueing into my video game, let's talk more about NIM. So the purpose of NIM is to deal more with the issue of internet surveillance. The thesis that we have here is that no existing solution can defend against the NSA and private companies and cyber criminals, well, like Google, Meta, and so on. Differentiating which one of those two go into companies and which goes into cyber criminals is an exercise left to the reader. We have some technologies, like for example, this clicker that doesn't work. I'm trying to click the button, but nothing is happening. It's not very effective, as Pokemon would say. No, still. Can someone skip? Whoa. Nope. That's too many skipped slides. Okay. Could someone please go back to the previous slide? Okay. Next slide, please. I'm just going to put this aside for now. All right. So there's a strong demand for privacy, which is why we're here. Tor itself keeps growing, especially when things happen around the world, like the Ukraine war or protests in Iran and other things. Also, Signal keeps growing, but the thing with Tor and Signal is that they lack what Nassim Nicolas Taleb would call an anti-fragile funding model. Namely, they're not resilient, rather, or they could be more resilient. Signal, which is an excellent contribution to online privacy, nevertheless had to be supported by an independent donation from Brian Acton, which is, one in a million sort of thing. And Tor has suffered from stagnating growth. Next slide, please. So our plan is to sort of offer a more decentralized and more incentivized mixed net that can provide better privacy than Tor, but also at the same time solving the resiliency, sustainability, and incentivization problems that may be faced by Tor or some other privacy-enhancing technologies. We do this with a token, and we also have some other technologies that I'll talk about in a bit, but first I would like to show you, next slide please, this comparison of how NIM is different from other similar technologies. So let's start at the bottom. When you're using a VPN, you're connected to the VPN, and your traffic just goes through the VPN and onto the website, whatever, Netflix that you're using or whatever it is. And there's no real anonymity happening here. You'll notice that these little dots, their ordering is the same. These are packets, their size is the same. Everything is the same, and the VPN itself, the VPN provider, can see all your traffic. VPNs don't really offer any anonymity, in my opinion. Tor is, of course, much better. Tor is a very nice technology that has actual onion routing, Packets are routed through a bunch of different Tor nodes operated by volunteers, and Tor has been very successful at helping activists and journalists and privacy-interested individuals over decades, I think. But nevertheless, packets can still be de-anonymized via their size and timing patterns. This is what we try to improve upon by using mixnet technology in NIM, which is an area of research that has existed for a while as well. It's better because it anonymizes the size and the timing of the packets. It mixes the ordering of the packets as well. To be fair, this leads to a slower service than something like Tor, but something a lot more secure, actually, in terms of anonymity. It can resist a much more capable global active attacker. Thank you for forwarding to the next slide. No, that was the good call, actually. So in our case, we have multiple hops, we have covered traffic, we have timing obfuscation, like I said. These are just, some of the technical ways in which we differentiate ourselves from existing privacy technology and hope to offer a better product to our consumers. Next slide, please. If you look at it from the perspective of the user, basically you're running the NIM client on your machine. We're using the Sphinx encrypted packet format to forward those packets through the mixed network, and then the mixed network throws the packets through the other side to the applications, services, friends, etc. And the service provider itself is free to run a service provider node, which interfaces with NIM for the user. And there's ways to get NIM running on the user's side. There's a way for service providers like Telegram or Signal to run NIM on their side as well. And so there's a diversity in the ways that NIM can be integrated across a stack, a product stack, or a network stack. Next slide, please. The NIM token is what handles the incentivization mechanism here. So when you run a Tor node, you just run a Tor node. And you're contributing to online privacy, but you're paying money to run the node, and there's no resilient incentivization mechanism that's happening there. But when you're running a NIM NIM mixed network, you're benefiting from the tokenomics present there, which are built on Cosmos, incidentally, because you are being rewarded via a proof of mixing. So there's a proof of mixing mechanism that looks at how much your mixed network node has actually, how much your mixed network node has actually mixed. And based on that, you get a token reward. So the more you mix, the more you contribute to online privacy, the more tokens you earn. And this hopefully will incentivize people to, and also establish a more resilient ecosystem for online privacy. The NIM token benefits the user because they can use it to access NIM. It benefits mixed nodes because they are rewarded for contributing to the NIM infrastructure and ecosystem. Validators, of course, exist to do what validators always do. You guys know about that stuff. And service providers, Signal, any other service providers, they can also purchase the token and provide it on behalf of their users so that their users can use their product with NIM for free. My job, like I said earlier, is the software integration aspect. And so I'm responsible for looking at how developers can integrate NIM into their products. One cool way that we're doing that is by offering a very nice set of SDKs. So we have a Rust SDK for NIM that allows to integrate NIM natively into any Rust application, get the cutting edge performance associated with Rust stacks. We also have a TypeScript SDK which allows you to interface with a WebAssembly version of the NIM client in the browser. And that's also very nice because it means that you can deploy NIM in browser extensions in any Atom or Tauri or Electron app. No, Atom's the editor. Electron app, and in the browser as well. And we also recently started working on finished actually and published in collaboration with ChainSafe, a libp2p native transport for NIM. So you know how in libp2p you can specify the transport and it comes with a bunch of transports like WebRTC, WebSocket, and Quick. Well, NIM is the only libp2p transport that provides full privacy mixednet guarantees. It's the first privacy-preserving native transport for libp2p implemented in Rust, and you can check it out on GitHub today. That's one of the ways in which we're bringing NIM integration to the general public in more and more ways. So it has a simple, well-specified Rust API. It's very nice. It does all the things that you would expect are done when you have good software engineering taking place. and all of that is there. When it comes to the users, we also want to make NIM more accessible to users themselves, like normal people who just want better privacy, not necessarily developers or anything like that. Right now we have this app. It's more of a proof of concept called NIM Connect, and it basically allows you to open up a proxy on your computer, and you can use that proxy to route Telegram through NIM and so on. But the idea is that we were going to expand NIM Connect to become the NIM app. So you just download NIM Connect on your computer, and then NIM Connect can detect, like, oh, you have Signal installed, you have whatever installed, and it'll automatically try to connect to these apps and route them through NIM for you. That's my goal, personally, I think it's a nice idea. We also have the NIM wallet, which is really nice, not only because it works on all desktops and it's nice user interface and so on, but it also has a good UI and UX for managing mixed nodes. So you can manage your mixed node from the wallet via a nice graphical user interface. You don't need to use the command line, even though your mixed node is running on a server somewhere. Isn't that cool? I personally, this feature was implemented before I joined NIM, and when I discovered it, I was really excited about it because it means that, not only trading NIM tokens, but also like just running a mixed node, managing the mixed node, all happens from one place, and that's very nice and allows a more integrated user experience for anyone who wants to contribute to the network. You can even monitor like the rewards that you're earning from your mixed node and so on. We also have this thing, which I don't really understand how it works quite yet, so I'll skip it. All right, so just honestly, basically this is what I just described. You have the mixed node rewards that are being determined via a Cosmos smart contract, that's being validated by a bunch of validators, the way that many services on Cosmos work. Instead of cryptocurrency mining, we have mixnet-based proof of mixing mining, and you can stake your NIM in mixed nodes to basically give a vote of confidence to them, allowing them to route more traffic and earn more rewards. So there's a staking element in the NIM token and the mixed node economics as well. And yeah, everyone is happy. I think this establishes an economic system where it works well for everyone. This year, in integration, we have upcoming work in terms of integrating native NIM support into applications. I had an encouraging discussion with someone here today who is looking at integrating NIM natively into a technology that you heard about earlier, and that's very nice. There's also going to be SDKs and layers for independent developers that just want to use NIM, and those exist already and are quite functional. And we also want to give users control themselves to just go ahead and download a NIM app and use it, right, without needing to deal with code bases and so on, because how will we reach the end user otherwise? That is going to be the ultimate test of the real-world viability of the technology and the product. Thank you very much for your attention today. NIM is a cool thing that you should check out. This is our website. Please feel free to send me an email. Make sure to hit like and subscribe, and stay tuned for more videos.
Thank you very much. Maybe there are some questions. Any questions? Oh, there are some questions.
Thank
Wonderful.
You. Yes. Yes, please.
Thank you. Do mixnet node operators do they also have to be validators, or are those two separate roles? And if so, how do they sort of work together?
NIM mixed nodes and NIM validators are two completely separate roles. They run two completely separate Rust binaries. There's NIM-mixed node and NIM-validator. Anyone can run a mixed node. Right now, in order to run a validator, well, you can run one, but to be listed as a validator, you have to basically contact NIM, not me, someone more politically involved, to be listed. The rewards for validators are also slightly different, I think, and I'm not really sure how they work. But it's a significantly very different role, I think. There's no overlap. Sure. The gentleman over here, yeah.
Just a quick question, kind of related. Who did your token economics? They're pretty good, and that's kind of rare for infrastructure projects.
The token economics were done many years before I joined the company, which is about 6 weeks ago. To be honest, I don't know. A good person to ask would be Harry Halpin, and this is my personal thinking. This might be totally false, but I think that someone from A16Z helped, but I'm not sure.
Okay.
What are your thoughts on other maybe more established projects like iCloud Private Relay and their sort of like, techniques? Do you think being mass market is better than what you're doing perhaps?
Well, I think that iCloud Private Relay is a very successful project, specifically because it has it outcompetes us and basically everyone else in terms of being able to give a strong user experience, to integrate with the user stack. And that is something that in general, cool crypto anarchist, whatever technology fails at so far, hence why they hired me 6 weeks ago as head of software integration, right? So in that sense, yes, we need to catch up to them. However, strictly speaking, our technology is superior when it comes to the privacy guarantees that it can offer. And that's just how it is, right? Like if you study it, if you do statistical modeling, if you look at the cryptography, it's just better. However, can we make it as performant and as seamless for the user? That's something that the field has always struggled to do. And recently, it's been taking these questions more seriously, and hopefully it will continue to do so.